Hello to all my fellow AP Calculus test takers. If you're preparing for the AP Calculus exam, this is the video for you. Today, I'm going to be studying AP Calculus and giving you some strategies to help you on exam day. Currently, it is the week before the exam for me, and so I am really locking in and learning all the things that I'm weakest on. I'm going to give you some tips for studying that helped me when I took the AP Calculus AB exam. I'm taking the BC exam next week. I'll also share some practice materials with you to help you prepare for exam day. One thing I found super helpful is keeping a list of all the information that I need to memorize but don't have memorized yet so that I can review it each day. This includes antiderivatives, convergence and divergence tests, and the conditions that go with each one of those. That's for BC Calculus exam only. I've also included some theorems that might be included on the exam, like the mean value theorem, the intermediate value theorem, even something like L'Hopital's rule. So that's the first thing that I review each day when I'm practicing. Most days, I'll go through an entire FRQ set. You can find all the AB and Calculus BC FRQ sets from the past online along with scoring guidelines. Even though College Board only has 3 years worth easily accessible on their website currently, you can still look up other years just by typing that into your Google search bar. Right now, I'm going through the 2016-2015 sets. This has really helped me to be able to improve my FRQ work. If I'm struggling with any particular type of problem, like Riemann sums, parametrics, that type of thing, then I can go and find the same type of problem for multiple years and focus on that instead of the broad swath of problems that are on every single test, which allows me to study my weaknesses. Now, one thing I did do recently was taking the multiple choice part of the exam, which is something that's really pretty much impossible to find online. There's a 1998, which I know sounds old, but it's very accurate to what they still have today. I took the AB version last year, and this was able to help me prepare and study for the AB 2025 exam. And I did the same thing with the BC exam this year. Because math stays very similar, the same content is generally tested, and the problems are very, very similar in style. If you do well on one, you'll do well on the other, and it'll help you figure out whether you're going too slowly, whether you need to go back and check your work more, what particular types of problems you're struggling with. If you want access to that, check out the description, because I've included the links for the AB and BC exams along with the scoring guidelines for the multiple choice. Now, to show you what it might look like as I'm studying for the FRQs, which is again what I'm doing most of the time, because when you study for those, you are by default also studying for the multiple choice, which are a little bit easier. I've included 2 FRQ work-throughs, one of which is AB with a calculator and one of which is BC without a calculator, just so you can see how I kind of go through it. I also use the scoring guidelines whenever I make a mistake or miss a point. I've also found Albert or any of the other score predictors really helpful as I've gone through the multiple choice and free response portions of the exams at home practicing, so I can get an idea of what my score might be on test day. But with that said, let's go ahead and get into it. These are problems from the 2016 exam. Here's a pretty common AB problem with no calculator. We have water is pumped into a tank at a rate modeled by W of T liters per hour in this interval, where T is measured in hours. Water is removed from the tank at a rate modeled by R of T, where R is differentiable and decreasing on the interval. Selected values of RT are shown in the table above. At time t equals 0, there are 50,000 liters in the tank. You estimate the derivative of R of 2. Show the work that leads to your answer. Indicate units of measure. This is pretty easy because we're just calculating the slope. So we're going to have R of 3 minus R of 1 divided by 3 minus 1. And that's going to be the same thing as 950 minus 1190, which divided by 2 is equal to negative 120 liters per hour squared. B says use the left Riemann sum with the 4 separate intervals indicated by the table to estimate the total amount of water removed from the tank during 8 hours. So let's do that part first. Left Riemann sum just means you're going to take the R of t at the farthest left point, so that's in this case it could be R0, and multiply it by the interval 1 minus 0 in this case, and we're going to add that to the next furthest left point, which is R of 1. We're going to multiply that by 3 minus 1. Same concept as before. Come down here, R of 3 times 6 minus 3 plus R of 6 times 2. And then we can use our calculators to figure that out. That equals 8,050 liters. Then we finish the problem with, is this an overestimate or an underestimate of the total amount of water removed, to give a reason for your answer. Well, when you have a left Riemann sum with an equation that's decreasing such as this, and you take the left intervals like this, you're going to have a big margin of error over here, meaning that, in fact, it's going to be an overestimation. Since R of t is decreasing, it's a left Riemann sum. C says use your answer from part B to estimate total amount of water in the tank to the nearest liter at the end of 8 hours. So our equation is essentially going to be that original 50,000, or 5 times 10 to the 4, plus the amount of water that's being added. So that's going to be equal to that integral of W of t from 8 to 0 minus 8,050 R of t, which we calculated earlier. That D. For the interval, is there a time t when the rate at which water is pumped into the tank is the same as the rate at which water is removed from the tank? Explain why or why not. So we want to find a time when R of t equals W of t. And in fact, according to the intermediate value theorem, there has to be a time when these two are equal. In your actual answer, you'd write intermediate value theorem down. We can see that W of t actually starts off much greater than R of t, and it ends up much smaller. And that just takes a couple of quick calculations by punching in t is 8 and 0 into your calculator, which means that at some point W and R are equal. So this is another problem, but it's BC and it is no calculator. The function f has a Taylor series about x equals 1 that converges to f of x for all x in the interval of convergence. It's known that f of 1 equals 1, the derivative of f at 1 equals negative 1/2, and the nth derivative of f at x equals 1 is given by that function for n is greater than or equal to 2. Write the first 4 non-zero terms in the general term of the Taylor series for f equals about x equals 1. This is a pretty popular thing for you to see on the AP exam. We have the pretty well-known formula that we can use that looks like this. Now we just need to find this equation, but for the formula above, when c equals 1. So we can figure out f of 1 equals 1 based on up here. Antiderivative of f at 1 equals negative 1/2. So we'll have that. And then it gets a little tougher because we have to start using this equation over here, but we just need to plug in 2 for n. So we'll have 1 divided by 4 times that. And then one more time, we've got to go through it, but this time we plug in 3 for n. Now we have to find the general term. If we look across all of these, we can drop the 1, and we see that we have alternating sequence, so negative 1 to the n. We also have some kind of x minus 1 to the n piece going on, and we have a 2 to the n piece. But along with that, we have this factorial piece down here, which we can cancel out so that there's just n, since there's 2 factorial pieces across that, and that would be our general term. B, the Taylor series for f about x equals 1 has a radius of convergence of 2. Find the interval of convergence. Show the work that leads to your answer. Now, it has a radius of convergence of 2, starting at 1, so that's pretty easy to figure out what the endpoints are. We've got a negative 1 and a 3, because you just have to add 2 and subtract 2 from that 1. And so in order to connect them, we do that, but we don't know whether x is greater than or equal to 1, or if it's just simply greater than. So we need to figure out whether there should be a line at those 2 points or not. And we can consider the portion from the general term that was like this, and we plug in -1, we see that we end up with a positive answer every single time. But when we plug in 3, we end up with an answer that alternates back and forth between positive and negative, meaning that we can include 3 in there, but we cannot include -1. The Taylor series for f about x equals 1 can be used to represent f of 1.2 as an alternating series. Use the first 3 non-zero terms of the alternating series to approximate f 1.2. So very similar equation as before, except we're going to plug in 1.2 for x, which when we simplify is equal to 1 minus 0.2 plus, and I know this is a quick thing, so you probably can't just do it in your head, but 0.05, and that would be the answer for this. But then asks us to show that the approximation found in part C is within 0.001 of the exact value of f of 1.2. So all we have to do is take the fourth part of the Taylor series that we found in part A and plug in 1.2 for x. And we can use this because of the alternating nature of the sequence. If this is less than 0.01, then we've proven it. So now we just have to quickly simplify. Can cross these out, release the factorial portion there. Then we have 2 to the third divided by 10 to the third divided by 24, which simplifies to, which is true. I hope you found this video helpful and it helps you as you go into your AP Calculus exams. If you did find it helpful, please like and subscribe. You can find some other AP related content on my channel along with things on SAT, college applications, so go check those videos out. If you have any questions, please throw those in the comments below. And again, thank you so much for watching. Good luck on your next exams, and I'll see you in the next video.